Okay, here's what I want to show today. Let's see. I made this conductive plastic. Some of my older videos show this. It's made from styrofoam, acetone, and graphite. And you can see that. You can see the sparkles in there. That's the graphite. There's probably two different kinds of graphite in there, the finer mesh and the heavy mesh. All right, the conductivity of this, I'll show you this, and it's right here. I've got it set up on ohms. So let's check out first on a centimeter. It's around 26 ohms. And I guess I'm not sure what a square would be. There's about an inch across. It's 230 ohms. Well, actually it's moving. Moves all over the place. Let's see. Let me see if I can poke it. 9 ohms, 10 ohms. That's an inch away. 18 ohms. So you can see it's fairly conductive. And what we're going to do is we're going to put it on top of this. This right here is another it's an electrolyte, but it's hard. I mean, it's made of the same material, and I'll show that in another video where I take the sodium silicate and I add I'm adding magnesium powder to this, and I'm also adding graphite to enhance the transfer of electrons, reducing the resistance in this material. And what I did was I put it on a piece of magnesium ribbon that had the sodium silicate and nanoparticles inside the sodium silicate, and I had that in there. I took this off the hot plate, and it was still kind of I guess you'd call it pliable, and I stuck it down on there, so it's kind of like glued in a way to it. All right, so and let's check the conductivity of it just for prosperity. Let's see, here's a centimeter. You can see it's not real good. It's about 80, 75. It's dropping on down. 50K. Anyway, it's way on up there. All right, it'll probably change over time. It's still kind of rubbery right now. All right, so now what I want to do is, well, here's another thing I'd like to see. Let's check the resistance between this material and that. And you can see between the ribbon, which you can see the ribbon is about 1 ohm. All right, between the ribbon and the outside of this magnesium silicate is it's an open circuit. There's no resistance. I mean, there's total resistance in between those two, so it's not there. All right, so what I'm going to do now is, for a reference, this is graphite, and I'm going to put the graphite on here, and we're going to check the not the resistance, but the voltage that we get. 1.2 volts. All right. Now the conductive plastic, 1.2 volts. Okay. I wonder if that made a difference there, where I had that tip wasn't screwed in good. .39 volts, 3.7. Let's try the graphite again. .2 volts. So the conductive plastic seems to be a little bit better as far as the voltage goes. Now, let's see what the amperage is. We got microamps here, so let's check this out. Okay, it's over 100 microamps. Okay. That's with the conductive plastic. The graphite oil, over 100. I kind of like the conductive plastic because it might be brittle, but it stands up much longer than the graphite oil does. It just takes longer to make this stuff. So we're still looking at a lot of current, and as you can see, one of the things that we want to check out is whether or not the crystal solution will protect the magnesium. We know that there's not a conductive, it's not conductive across as far as how much resistance there is, but current does flow through it. So in a previous video I checked this with the meter, and I want to find out how long this will last with the crystal structure on top of it. Does it keep producing the energy or not? So what we'll do, just periodically check it. I'm going to put this conductive plastic on here. And it looks like it. So what I'm going to do is I'm going to set this up to where I'll put it on a drain, basically a short across it, and just see how long this lasts. I need a motor that I can hook it to, like maybe one of those little solar motors, and that would really help out. But since everything is sort of in a crystal form or in a hard form, which is odd. This is only like a piece of metal right there. There's no fluids in here other than what tiny bit is left in the sodium silicate. So we will see how long this will last. Okay, on to the next thing.